Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2017, Foundation Tier, Paper 3. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. Circle the cube number. Well, we've got some numbers here. 100. What's 100? 100 is 10 times 10, isn't it? Which is 10 squared, so that's not a cube number. 1,000 is 10 times 10 is 100 times 10 is 1,000, isn't it? So it's 10 times 10 times 10, which is 10 to the 3. I think that is a cube number. Do we have any more cube numbers? No. 10 to 10,000 is 10 times 10 times 10 times 10. 10 times 10 4 times. And 100,000 is 10 times itself 5 times. So the only cube number in that list is 1,000, which is 10 by 10 by 10. Question 2. A fair ordinary dice is thrown once. Circle the probability of getting a 2 or a 3. Now you should recall that probability is given by successful outcomes divided by total outcomes. So to work out probability, you need to know what those two values are. So the total outcomes are all the different ways or all the different things that could happen when you throw a dice. So there's 6 faces on a dice, so there are 6 things that could happen. So there are 6 outcomes altogether. And successful outcomes here, we've got the 1, 2, 3, 4, 5, 6 as our 6 different outcomes. And here, the successful outcomes are the 2 and the 3. So 2 of my outcomes are successful. So that makes it 2 over 6. That one. Question 3. Circle the decimal that is greater than 1/5 and less than 1/4. Okay, now hopefully you know how to convert these common fractions into decimals. If you don't, you can just simply type 1 divided by 5 equals into your calculator and then display that as a decimal. You should find out that this one is 0.2 and this and a quarter doing the same way, if you don't remember it, is 0.25. Now you notice that each of these numbers below are given to 3 decimal places, so let's add some zeros on the end of these so it makes it a little bit easier to compare. So we want to have a decimal that is greater than 0.200 and less than 0.250. Well, it's not that one, is it? It's too low. That one is the same as the bottom one, so it's not that one. That one is in the middle, and that one is bigger than the quarter, so it's not that one. So it's 0.215. Question 4. What is a litre a unit of? Circle your answer. Okay, well you probably know that litres, what comes in litres? Well, milk comes in litres. Fizzy pop comes in litres, juice comes in litres, so it's kind of a measure of how much fluid you have in a container, so it's not area, is it? Density is how heavy something is per unit volume, so that's not that one. Mass, no, it's not a measurement of mass, it's a measurement of capacity, how much space is inside a container. So it's going to be capacity. Question 5. 2.5 kilograms of carrots cost £1.70. Work out the cost of 3.25 kilograms of carrots. Now I'm going to use a method here, a ratio method here called the unitary method. So we're going to start with our weight of carrots and our cost of carrots that we were given. Now we're told that 2.5 kilograms of carrots cost £1.70. So I'm going to write that in as a ratio. 2.5 goes with 1.7. Okay, and it's called the unitary method because it means you go via a unit or the number 1. So I'm going to work out the cost of 1 kilogram of carrots, and then I'm going to scale it back up and work out the cost of 3.25. Now in order to do that, I need to take this value, I need to divide it by 2.5, and then I need to times it by 3.25. So if I do that on the left hand side of my ratio to make things all stay in proportion, I'm going to do the same thing on the other side. So divide by 2.5 first and then times by 3.25. So reaching for a calculator, I just type in 1.7, divide it by 2.5 to find the cost of 1 kilogram, and then times it by 3.25. Don't really need to write down the middle value if I don't want to. It's just the answer down here that I need to find. So 2.21 is the solution, isn't it? So that means that 3.25 kilograms of carrots costs £2.21. Gina makes a sandwich using bread or a roll and ham or cheese and salad or pickle. List all the possible types of sandwich Gina could make. One has been done for you. So it's written down BHS, which stands for that she had it on bread, she had ham in it, and she had salad. Okay, so we need to come up with all the other possibilities. Now I tried to do these systematically, so you keep as much the same and kind of go through it in an ordered way. So let's keep the first 2 letters the same first off and then switch the last one. So we could have bread, ham, but instead of salad we're going to have pickle. Okay, now I'm going to try and keep bread the same as long as possible. So I've done all the options with ham now. So let's switch ham out to cheese. Now I can have bread, cheese and salad, or I can have bread, cheese and pickle. Okay, so that's all my bready, cheesy options. And I think that's all the ones that I can have with bread, isn't it? Because I've got bread and ham and cheese, bread and ham. So let's switch to rolls this time, and we're going to have pretty much the same method. So we're going to start with roll and ham and salad, and then I can have roll and ham and pickles. And then I can have roll and cheese and salad, and then I can have roll and cheese and pickle. Okay, so because I've gone through this in an ordered way, I'm pretty confident that I've got through all the list. And you can see there are 8 different possible sandwiches then you can make with these different pairs of ingredients. So what fraction of the possible types of sandwiches have cheese and pickle? So let's go back to our list. You can see that this one has got cheese and pickle in, and this one is cheese and pickle in. So that is 2 sandwiches out of 8 sandwiches then. So the fraction of possible sandwiches that have cheese and pickle are 2 out of 8. Now you could simplify that down to 1/4, but you're not going to get any extra credit if you do or you don't. So either of those answers is acceptable. Question 7. ABC is a right angled triangle. A is the point -3 -2. B is the point 1 -2. And C is a point on the line y is equal to 4. Draw triangle ABC on the centimeter grid below. Okay, so A is the point -3 -2. So -3 -2 along the corridor up the stairs. -3 -2 takes me to this point here. So that is going to be my point A. So there's A. Okay, my next point is the point 1 minus 2. So along the corridor, up the stairs, it takes me to this point here. That's 1 minus 2. That's going to be B. And we know that C is a point on the line y is equal to 4. Okay, so y is equal to 4 is a line which is parallel to the axes. So that is the line. Y is equal to 0, y is equal to 1, y is equal to 2, y is equal to 3, y is equal to 4. So our point C is a point somewhere along this line. So let's just draw that in red for now. Somewhere along there. We're not quite sure where yet. So draw a triangle ABC on the centimetre grid below. Now, it doesn't tell me where C is, so perhaps it doesn't matter. So C, I suppose, could be anywhere along there. Let's put it... Oh, it's a right angle triangle, sorry. I missed that bit at the beginning. I was a bit puzzled for a bit. It's a right angle triangle, so we have two choices of where we can put C. We could put C here, or we could put C here and form a right angle triangle. Either of those 2 points would be okay. I'm going to go for the one on the left. Okay, so the one on the left, then draw my triangle. So from C down to A, across to B. Okay, so that was C up there. There's my right angle. Okay, so then next it says work out the area of triangle ABC. Well, the area of a triangle is given by the formula half base times height. Now the base is this line here, isn't it? And that is 1, 2, 3, 4 units across. The height of my triangle is this side, and using the squares to count up 1, 2, 3, 4, 5, 6. It's got a height of 6. So height 6, base 4. Let's sub those into the formula and find out the area. So that's a half times the base, which was 4, and the height, which was 6. So half times 4 times 6. Now you can either multiply the 4 and the 6 together, give yourself 24, and then halve it, give yourself 12, or you can halve one of the numbers and then multiply it by the other one. So half of 4 is 2, and 2 times 6 is 12. Either way, the area is 12 centimeters squared. So the answer is 12 centimeters squared. Question 8a. Complete the number machine so that Q equals 7R minus 2. Now you can see that R is the input. Here it is, so the R appears here in the equation. Now to work out Q, we're going to take R, we're going to multiply it by 7, and then we're going to subtract minus 2. So thinking through in terms of bid mass, what we're going to do first, we're going to do the multiplication first, because multiplication comes before subtraction. So we're going to take our value of R, we're going to times it by 7, and then we're going to subtract 2. And what do we get? We get Q. So Q comes at the end. Okay. Now in question B, we have to kind of do the opposite of that. Write down the output of Y in terms of X. So here we've been given the function machine, and we need to kind of recreate the equation like we did it with how we started the first question. So the output is what you get. So you'll notice here that the output that you get is actually at the start. So we're going to do the same thing here. So our output is going to be Y, and it's going to be at the start. Then let's think about what happens with X. So we're going to take X, we're going to put it into this box here, and we're going to add 5 to it. So Y is going to be X plus 5. Now once we get to there, the next thing we're going to do is multiply it by 3. Now you need to take care here. If I just write times 3 at the end like that, that is not going to be correct, because of the laws of bid mass, order of operations, that actually means 5 times 3 added to X, which is not what we're doing here. We're taking the whole of X plus 5 and multiplying it by 3. So we can either write like that in brackets, or an even neater way of writing it would be to write the 3 at the front here. So it's 3 lots of x plus 5. So like I say, you can either write it like that, or you can write it with the times 3 at the end, but you must have the brackets in. Okay, I'm going to leave it in the slightly neater form like that. Okay. Question 9. A farmer has 580 eggs to put into boxes. The boxes come in 3 sizes. So we've got a box for 20 eggs, we've got a box for 12 eggs, and we've got a box for 6 eggs. Now it says that he wants at least 10 boxes of 20 eggs, and at least 15 boxes of 12 eggs, and at least 25 boxes of 6 eggs. The farmer fills 54 boxes with the 580 eggs. Show how he does this. Okay, so I think probably the easiest way to attack this is to let's put his minimum order in first, and then let's see what we've got left. So if he has at least 10 boxes of 20 eggs, then that is going to be 10 times 20, which is 200 of his eggs straight there, isn't it? Okay, then if he's got 15 boxes of 12 eggs, then 15 times 12, 10 12s is 120, 5 12s is 60, so that's going to give me 180 altogether. And then we've got 25 lots of 6. I know 4 25s are 100, so 6 25s must be 150. So how many eggs have we already allocated on his minimum boxing requirements? So 200 added to 180 added to 150. So reaching for the calculator, 200 plus 180 plus 150, that gives me 530. So he's already put 530 eggs just doing his minimum orders down here. So we've dealt with, oops, I meant to do that with highlighter. So we've dealt with all of those. Now, how many boxes have we used? We've used 10 boxes of size 20, 15 boxes of size 12, and 25 boxes of size 6. So how many boxes is that altogether? So we can add those up as well. 10 plus 15 plus 25. I don't need a calculator to work out that that's 50. So let's compare what he's got so far with what he has to fill. So far we have used 50 boxes and we've filled 530 eggs. So then compare that to what the number of boxes he's going to end up using and the number of eggs he's going to end up using. You can see that we've got 4 more boxes to fill, and we've got to fill it with 580 subtract 530. We've got to put another 50 eggs in 4 boxes. So we have 54 minus 50, which is 4 more boxes. And we have 580 subtract 530, which is 50 more eggs. Okay, so we've got to put 50 eggs in 4 boxes. So how are we going to do that then? Well, I suppose if we put 20 in there, let's have one of those, and then we've got 30 eggs still to place. So then if we have 2 of those, 12 and 12 is 24, so 20 and 24 gives me 44, and then one of those. So that seems to work, doesn't it? So a box of 20, 2 boxes of 12, and a box of 6. So we use 1 more box of 20, 2 more boxes of 12, and 1 more box of 6, which is 6. So that gives us our 50 eggs, and it gives us our 4 boxes. So in total then, we're going to be using, for our boxes of 20, we've got 10 boxes there plus another 1, which is 11. So 11 boxes of 20. We've got 15 boxes here and another 2 here of size 12. So that gives me a total of 17. And finally, I've got 25 5 boxes of size 6 here and another one here. So that makes 26 boxes of size 6. So we can just double check that that adds up to the total amount that we need. 11 plus 17 plus 26 gives me 54 as expected. Always good to just to do some double checking of your work in any other way that you can to make sure it's right. Question 10. Megan says if you add any 3 multiples of 10, the total must be a multiple of 10 and a multiple of 3. Is she correct? If you add any 3 multiples of 10, then the total must be a multiple of 10 and a multiple of 3. Well, let's just try a few examples. So if you add any 3 multiples of 10, so multiple of 10 would be any numbers in the 10 times table. So let's have 10, 20, 30, the first 3. If I add those up, 0, 0, 0, 1, 2, 3, that adds up to 6. So 60. Is 60 a multiple of 3? 60 divided by 3 is 20. So yes, that is a multiple of 3. But is it always the case? What about if I had 10, 20, and 20? Now that adds up to 50. Is 50 a multiple of 3? No, because if I try and divide 50 by 3, I'm going to get a fraction, 16.16 and 2/3. So that one is not a multiple of 3. Okay, so how are we going to answer this question? Is she correct? She is not correct. That should hopefully give us one of the marks. And the example we give, because 10 plus 20 plus 20 equals 50, and 50 is not a multiple of 3. Question 11. A fair spinner has 12 equal sections. Label each section A, B, C, D so that when the arrow is spun, the probability that it lands on A is a 1/6. The probability that it lands on B is equal to the probability it lands on C, and the probability it lands on D is double the probability that it lands on A. Now our spinner's been divided up into 12 sections, so we need to be working out in fractions of 12 how many of these are going to be of each sort. So the probability that it lands on A is 1/6. Now I can rewrite that as a fraction over 12 just by multiplying top and bottom by 2, can't I? What I do to the bottom I have to do to the top. So 6 times 2 is 12, 1 times 2 is 2. So that means 2/12 of my spinner have to have the number A on, or the letter A on them. So let's take this first one here and say that one must be A and that one must be A. So then I've got 2/12, the probability of 2/12 it's going to land on an A1. Okay, so the probability it lands on B is equal to the probability it lands on C. So we don't know, we just know that B and C must be the same number of sections. And the probability it lands on D is double the probability it lands on A. Well, that one we can do straight away, because I know that 2 times 2/12 is going to be 4/12. So we're going to have 4 D's. D, 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 D. And then I have to have the same number of B's and C's. So I've got 6 left. So I'm going to give 3 to the B's and 3 to the C's. So then I've got the same number of B's and C's. Okay, so I'm done. Good job. Question 12. A minus B is equal to 5. Part A says work out the value of 2 lots of A minus B. Now note that we don't know what A and B are, but we do know that A subtract B is 5. It's given here. So if A minus B is equal to 5, I can replace this A minus B in here with the value of A minus B, which is 5. So in other words, I've got 2 lots of 5 here, and 2 lots of 5 is just 2 times 5, which is 10. Okay, so work out the value of 2 lots of A minus B. The answer is 10. Okay, now part B says work out the value of 7A minus 7B. Now can we do something similar here? Now you notice I've got a 7 and a 7 in both terms. So they're common, aren't they? So I can factorize out that 7 and rewrite this expression as 7 lots of a minus b. Now again, I've got this expression at the end here, which is a minus b, and I know that that is worth 5. So then I can do the same thing. I can replace it with the value 5, and 7 5s are 35. So 7a minus 7b must be equal to 35. And then finally it says work out the value of b minus a. Okay. How can I work out the value of b minus a? A minus b is equal to 5. What is the value of b minus a? Now there's a quick and easy way of doing this. It's moving everything around on the equation. So if I take this minus b and take it to the other side, it becomes plus b. If I take this 5 and move it over here, it's going to become minus 5. And if I take this a and I move it over here, it's going to become minus a. So you can see that b minus a, which is what I was trying to find, is equal to negative 5. So the answer is negative 5. Now this is using something, a quick shorthand method of rearranging called change sides, change signs. So it might be something quick and easy that you can remember. So if you take anything from one side of an equation over to the other side of the equation like this, you have to flip its sign as it goes over. So that a became a minus a, the minus b became a b, and the 5 became a minus 5. Question 13. A cube has edge length 0.9 meters. Work out the total surface area of the cube. Give your answers in square centimeters. Okay, so notice first that that's in bold, and normally things in bold are there because students will otherwise not see them. So just take extra care when things are in bold. So square centimeters, this measurement is in meters we've been given up here, so we need to convert that into centimeters first, and if we're going to work this out in centimeters. So let's convert that to 90 centimeters. So this is 90 centimeters by 90 centimeters by 90 centimeters. Okay, now a cube is made up of 6 equal faces, and each face is a square, and 90 times 90 is the area of each square. So the total surface area of this cube is going to be the area of one face, which is 90 times 90, times by the number of faces, which is 6. So we're going to find 6 faces, and each face is 90 by 90. So the total surface area is going to be 6 times 90 times 90. So tapping that into the calculator, 6 times 90 times 90 gives me the answer of 48,600 centimeters squared. 48,600 centimeters squared. Okay, let's just write it down in the bottom. Oops, let's write in the bottom properly. Okay, done. Question 14. £1,700 is invested for 3 years at 4% per year simple interest. Now, note again, the word simple has been bolded. Take note. Okay, so there are 2 types of interest. There's simple and there's compound. Simple interest, you just work out the interest on your base amount over and over and over again. Compound interest is a little bit more complicated. This is quite easy actually. We just need to work out 4% of 1,700 and then times it by 3. Okay, so what is 4% of 1,700? 4% is, as a multiplier, is 0.04. Okay, so final original multiplier. These are the 3 values we need to know. We know this is 0.04, that's the interest rate. The original amount is 1,700. The final is what we're trying to find. So there's a handy little triangle for this final original multiplier. So my final amount is going to be my original amount times my multiplier, which is, the original amount is 1700 times my multiplier of 0.04. Now that is just going to give me a one lot of interest. And we'll have to then take that answer and multiply it by 3. So I might just add that on the end. So I'm going to do that 3 times. So 1700 times 0.04 times 3 gives me a 204. So simple interest is £204 on that amount over 3 years. 204. Now, if this had said compound interest instead of simple interest, rather than multiplying by 3 here, we would be raising that to the power 3. That's the difference between simple and compound interest. But here we're doing simple interest, so we're just going to multiply by 3 rather than raising it to the power of 3. Question 15. Here is a map showing 2 towns P and Q, and 1 centimetre represents 50 kilometres. So work out the actual distance between the towns P and Q. So we need to know the distance between these two. So you're going to need a ruler. Now you'll notice my ruler doesn't have any numbers on it, and actually I don't really want to try and use it to measure this distance because this is on my computer screen and it might not be accurate. But what you want to do on your paper is to carefully measure this distance with a ruler. Okay, now I'm told from the mark scheme that is actually 7 centimetres from there to there. Now, it might be that you're doing this on a practice paper that your school has printed out for you. Now again, sometimes when these papers are reproduced by graphics departments in school, they get slightly stretched or squished. They're not quite the same size as the original paper. So when you measure this on your ruler, on your practice paper, it might be slightly out. But don't worry, the real paper will be real, and you'll be able to measure that with your ruler as long as you know how to use a ruler. So I've measured that, and anyway, it's 7 centimetres. How am I going to work out the actual distance then? So 1 centimetre is 50 kilometres. So 7 centimetres is going to be 7 times 50 kilometres, isn't it? 7 times 50 is 350 kilometres between those two towns. So work out the actual distance. It's 350 kilometres. Now, town R is 200 kilometres due south of town P. Mark R on the map. So we need to draw a line due south of line P. So we need to draw a line straight down there. I don't think we need to construct it in any way. We just need to try carefully draw in a southerly direction for a distance of 200 kilometres. So 200 kilometres, if I want to work out how far I need to draw, I need to divide that by 50 this time, don't I, to work out the number of centimetres. So how many 50 is going to 200? It's 4. So I need to draw my line 4 centimetres down. So you can maybe use... I'm losing my voice here. So you can maybe use this edge down here to help you align your ruler nicely, so it's going directly down, and then measure a distance of 4 centimetres directly down from P. I'm just going to have to guess because, like I say, my ruler won't match up with the diagram. So it'll be somewhere like that after you've measured carefully 4 centimetres downwards using your ruler. And then you're going to, don't forget to do this bit here, mark R on the map. So if you don't write R, you may lose a mark. So there we go. So it'll be somewhere down there. Like I say, I didn't do that accurately because my ruler is rubbish. It's got no numbers on it. Question 16. A train has 1 first-class carriage and 6 standard carriages. The first-class carriage has 64 seats, and 3/8 of those are being used. Each standard carriage has 78 seats, and 7/13 in each carriage are being used. Okay, so are more than half the seats on the train being used? You must show your working. Okay, well, what is the total number of seats on this train? Let's work that out to start with. So total seats, that is going to be the 64 first class seats and the standard coach seats. And now we've got, how many of those did we say? There were 6, weren't there? So there's 6 standard carriages, and they each had 78 seats. So that's a total of 6 times 78 seats. So 6 times 78, 6 times 78, and then we're going to add on 64. That gives me a total of 532 seats. Okay, so we're told that 3/8 of the first class carriage are being used. So occupied seats, that's going to be 3/8 of our 64 first class seats. And you can do this as a separate calculation if it's easier for you. We're going to have 7/13 of our 78 seats in standard class 6 times over. So what is that then? So 3/8 of 64, that is 24 seats, plus 7/3 of 78, which is 100, no it isn't, 7/13 of 78, that's 42 seats, times 6. 42 times 6, 252, add 24, is 276 seats. So we've got 276 seats occupied, and 532 seats in total. So are more than, again look, notice it's bold again, always take care with bold, are more than half the seats of the train used. I suspect there's a little twist in the tail here. So fraction that is used, so used is 276 over 532. Now we can use our calculator to cancel that fraction down for us. Let's just tap it in as a fraction and let the calculator work it out. So that's 69 133rds. Is that more than half? What's that as a decimal? That's 0.51879. I'm going to round it off to 0.52. Okay, it's just a little bit more than a half then, isn't it? Because half is 0.5 and this is 0.52. So it's a little bit more than a half. So are more than half of the seats on the train being used? Then the answer is yes. Question 17. Circle the equation which has solution x is equal to 6. Right, so we need to solve all of these then, don't we? That's quite a lot of work, isn't it? Okay, well maybe we can rule some out. So x divided by 6 is 0. So cross multiplying that 6 up there, 0 times 6 is still 0. So that's going to give me x is equal to 0. So that one isn't it. 3x is equal to 36. Dividing both sides by 3. It's going to give me x is 12. So that isn't it either. Okay, what about these other two? These are a little bit more complicated, aren't they? So we could try and solve them, or we could be a little bit smarter and make things easier on ourselves and just sub these values of x in to see if they're true. So are these expressions true if I made these values equal to 6? That might be easier than rearranging them. So is 6 minus 3 equal to 6 divided by 2? Well, 6 minus 3 is 3, and 6 divided by 2 is 3, so yes, that is true. What about the other one? Is 6 equal to 3 plus 6 divided by 2? Well, is 6 equal to 9 divided by 2? Well, 9 divided by 2 is not 6, it's 4.5, isn't it? So that is not true, which means that that one has a solution that x is equal to 6, and that one doesn't have a solution that x is equal to 6. So it's the first one. Now you could have done the same thing with these ones over here. You know, I could also sub in x is equal to 6 into here. 3 times 6 is 18, that's not equal to 36, and we could have done the same thing over here. 6 divided by 6 is 1 and not 0. So that subbing in method is sometimes quite useful to do these sorts of questions. Okay, let's move on. 18, x is greater than 5 and less than or equal to 9. Circle the identity that shows this. So x is strictly greater than 5. So it's not that one because that's greater than or equal to 5. And it's not that one because that's greater than or equal to 5. So it's either one of these two at the other end. So look, x is in the middle here, and the little end is pointing at the x here, and the big end is pointing at the 5. So that's actually saying 5 is greater than x, or x is less than 5, not greater than 5. So it's not that one either. Just by looking at the first part, you can work out that it's actually x is greater than 5 is that one, and strictly less than, less than or equal to 9. So it's that one on the end there. Question 19. The following data comes from a large sample survey of the audience at a concert. So we've got male and female on one side, and we've got a percentage. So that's a percentage, I suppose, of how many people attended. Their mean age and their age range. Okay, so let's make 3 comparisons of male and females at the concert using the headings given. Okay, so the proportion of the audience. Now the proportion is how many males there are to females, aren't there? And you can see here that there are many more males than females. So I'm going to say there are many more females than males at the concert. Okay, and the next one wants us to look at their average age. Now we've got their mean age here, haven't we? So we can say that on average the females were older than the males. The females were older than the males on average. And what's the last one? The spread of their ages. That's the age range up here, isn't there? So there's more variation in the females' ages than the males. There is greater variation in age range for the females than the males. Here we go. Question 20. In a tennis tournament, 98 players took part in the singles only, 34 players took part in the doubles only, and twice as many players took part in the singles as took part in the doubles. How many players took part in both the singles and the doubles? You may use the Venn diagram to help you. Okay, so let's have a look at each one of these statements. 98 players took part in the 98 players took part in the singles only. That means in my diagram down here that 98 goes here. That means it's in that they took part in the singles but not the doubles, so it's the left hand part of this singles circle. And we know that 34 players took part in the doubles only, so I can write 34 in the right hand side of this circle. And we know that twice as many players took part in the singles as took part in the doubles. So we need to work out this number in the middle, basically, don't we? So that the numbers that took part in the singles is twice as many as that took part in the doubles. So these two together should be twice as big as these two together. In other words, 98 plus x is going to be equal to 2 lots of x plus 34. Okay. So I've formed an equation in x here, which I can then go on to solve. I can just remove the brackets. That's 2x plus 2 lots of 34 is 68. So 98 plus x equals 2x plus 68. Taking that x over to this side and taking that 68 over to here, I'm going to get 98 subtract 68 is equal to 2x subtract x. 2x subtract x is just x, and 98 subtract 68 is 30. So that tells me that in the middle here I've got 30. So x was equal to 30, wasn't it? Okay, so how many players took part in both the singles and the doubles? It is that lot in the middle we've just found, which is 30. So the answer is 30. The distance by road from Newport to London is 140 miles. Tom travels by coach from Newport to London. The coach leaves Newport at 1:30 p.m. He assumes that the coach will travel at an average speed of 50 miles per hour. Use this assumption to work out the arrival time in London. Okay, we were just talking about the DST triangle, so let's just draw that out now. Distance, speed, time. Right, so what have I got here? I've got the distance. That is 140. Time is what I need to work out, isn't it? I need to work out the time he arrives in London. And I know the average speed is 50. Okay, that's in miles and that's in miles per hour. Okay, so the one I want to find is t. So kind of putting your thumb on top of the t, it tells you what to do with the other two. Time is equal to distance divided by speed. So time taken is equal to distance travelled divided by average speed, which is 140 miles divided by 50 miles per hour, which gives me 140 divided by 50. It's giving me 2.8. Now that's a decimal number. So it's 2 hours and 0.8 of an hour. So how many minutes is 0.8 of an hour? Well, there are 60 minutes in an hour. So 0.8 of an hour, 0.8 times 60 is going to give me 48 minutes. So that is equals to 2 hours and 48 minutes. Okay, so if we remember, we left Newport at 1:30 p.m. So if we're traveling for 2 hours and 48 minutes, so I'm gonna have to add that time on then, aren't I then? So 1:30, 2:30, 3:30. 30 minutes takes me up to 4 o'clock, and then I've got another 18 minutes after that to add on. So that's 4:18, isn't it? So 4.18 p.m. In part B, we're told that in fact the coach has a lower average speed than this, so it's not going as fast as 50 miles an hour. So this speed here then is going to be less than it used to be. Okay, so if you're going to divide through by a smaller number, then this number is going to get bigger, isn't it? So if you divide by something by a smaller number, you're going to get a bigger result. So that means the time is going to increase. So, and if the time is going to increase, then I'm going to be arriving later than the time that I had before. So in fact, the coach is going to arrive later. It will arrive later than planned. ABCD is a parallelogram. AB is equal to BP. And we've got the diagram there. Some of the information is already marked on there. I can see on the diagram already that they've marked that AB is equal to BP. But actually, they haven't marked on this information, have they? That ABCD is a parallelogram. Now, if ABCD is a parallelogram, it means that this line here, AB, is parallel to this one, CD. And the baseline here, BC, is parallel to this line up there. Okay, now that information isn't on there, it's quite important. So I'm going to add it on. Now we need to work out the size of angle X. You'll see that X actually appears in two instances here. I've got it here and here. Together they make 4X down there, don't they? Okay, I'm not quite sure I'm going to get over there yet. Now I have to start with the angle that they've given me over here. And that one lies in an isosceles triangle here. And that's one of the base angles of the isosceles triangle, isn't it? So if that 51 is one of the base angles, then that angle up there is the other one. So that one must also be 51. And if those two are 51, then this one up here must be 180 minus those two lots of 51, isn't it? So 2 times 51. So 2 times 51 is 102, and 180 subtract 102 is going to give me an angle of 78 degrees. Okay, so that's 78 degrees in there. Opposite angles in a parallelogram are equal. So I know that that one up there is going to be 78 also. Okay, can I work out X yet? Don't think so. Got some more work to do somewhere, I think. I think the best way now is to use the properties of parallel lines. Now, if you've got a pair of parallel lines and a line crossing them, then that forms a bunch of angles. And you should know that you've got corresponding alternate and supplementary angles. And here we've got a pair of supplementary angles, haven't we? So my two angles down here, my X and my 3X, are going to have to be supplementary to my 78. In other words, that those two angles sum to 180 degrees. Okay, so I know that X plus 3X, which is 4X, plus my 78 degrees must be equal to 180 degrees. Okay, because those two angles are supplementary. So taking the 78 to the other side, that means that 4x must be 180 subtract 78, which is 102. And that means that x must be 102 over 4, which is, what's that, 25.5? 25.5 degrees. Okay, so that's my answer, 25.5 degrees. Question 6. Show that 268 can be written as the sum of a power of 3 and a square number. Okay, in other words, we need 3 to the power of something plus something squared, and that is going to be equal to 268. Okay, now, probably the easiest way of going about this is just by just being systematic. Let's start with let's start with 3 to the power 1 and then see what the remainder is and see if that's a square number, and then we'll build up our powers until we find the right answer. So 3 to the power 1 is just 3, isn't it? So what would I have to add on to 3 to get 268? I would have to add on 265, wouldn't I? 265 plus 3 is 268. Is 265 a square number? Not that I know of. I don't think so. So let's try the next one. So the next power of 3 is 3 squared, which is 9. And 268 subtract 9 is 259. Again, is 259 a square number? It's not one I recognize. So let's carry on with this process. So 3 cubed is 27. 268 less 27 is 241. Now I kind of know all the square numbers, and these aren't square numbers that I recognize, so I'm just going to carry on. 3 to the 4 is 81, and 81 subtract from 268 is 100 and what's that, 187? Again, having memorized the first few squares, I can recognize that that isn't one, so I'm going to carry on to the next one. 3 to the power 5. Now, you might not know that off the top of your head. You can just type it into the calculator. 3 to the power of 5, 243. 243. 268 minus 243 leaves us 25, doesn't it? And 25 is a square number. So, show that 268 can be written as the sum of a power of 3 and a square number. So then I can just write that 268 is equal to 3 to the power 5 plus 5 squared. Done. Question 24. Y is inversely proportional to x and k is a constant. Circle the correct equation. Well, if y is inversely proportional to x, then we write that down as y with this little fishy symbol, and inversely proportional means 1 over x. So y little fishy 1 over x. You can then replace that little fishy thing, that the proportionality sign, by putting an equal sign and substituting in a k. So y is equal to k divided by x. It's that one there. Question 25. Pressure equals force divided by area. Work out the force when the pressure is 24 Ns per meter squared. I suppose that's newtons, isn't it? 24 newtons per meter squared, and the area is 3 meters squared. Circle your answer. So we know that pressure equals force divided by area, and we want to work out the force. So let's just rearrange this this formula first. If we move it up there, we should be able to see that force is equal to area times pressure. Okay, so we know that the pressure was 24 and the area is 3. So 3 times 24, 3 times 24, that's 72. So the force is going to be 72 newtons. It's that one there. 42 men and 38 women visit a restaurant. 44 of these people have a voucher. 3 times as many men as women do not have a voucher. Complete the frequency table. Okay, so we're starting with this first circle, which I assume means everybody. How many people are there altogether? We've got 42 men and 38 women, giving us a total of 80 people. So we can have 80 people to start off with in this circle here. Okay, so how many are yes and how many are no then? So 44 people have a voucher. So that means that 44 people, yes, they do have a voucher. And then 80 subtract 44 is going to give me 36 people who no, don't have a voucher. And then, okay, 3 times as many men as women do not have a voucher. So that means for every 3 men we have here, we've got 1 woman. In other words, I want to take the number 36 and I want to divide it into the ratio of 3 to 1. Now, 3 plus 1 is 4, so if I take 36 and I divide it by 4, I'm going to get 9. That tells me how many shares each person is going to get. So multiplying 9 by 3, I'm going to get 27, and multiplying 9 by 1, I'm going to get 9. So that means dividing 36 in the ratio of 3 to 1 gives me then 27 men don't have a voucher, and 9 women don't have a voucher. Okay. Right, how are we going to work out then men and women who do have a voucher? Okay, I think what we're going to have to use is this piece of information at the top, that 42 men and 38 women visit the restaurant. If I know that 42 men visit the restaurant and 27 don't have a voucher, then 42 subtract 27 must have a voucher, and 42 subtract 27 is 15. And I know that 38 women altogether visited the restaurant, and only 9 of them had didn't have a voucher. That means the frugal women must have had, well, there must have been 29 of them then, mustn't it, that did have a voucher. Obviously better at planning ahead than the chaps. 29 and 9 makes 38, that's right, isn't it? So that is my final chart. 11b. A voucher takes 15% off the bill. After using the voucher, the bill for a meal is £27.20. How much was the bill before the voucher? Okay, so I teach my students how to do percentage questions using this triangle, FOM. I tell them to put their thumb on it and work out which is which. So F stands for final, O stands for original, M stands for multiplier. So I asked them to identify each of these 3 things. So a voucher takes 15% off the bill. So the multiplier then, if you've got 100% and you're doing a 15% deduction, that is going to leave you with 85%, giving you a multiplier of 0.85. Okay, after using the voucher, so that bit of information is there. So after using the voucher, the bill for the meal is £27.20. Now you need to use your past, present, future tense to work out which is which often with these sorts of questions. So after using the voucher, the meal is £27.20. So that we've been given is the final amount. Okay, so the final amount is £27.20. Okay, so the original amount before the deduction is the one we don't know and the one we want to find. Yeah, look, there it is, before. So that's got to be the original price. So what this method does is says is you cover up the one you want to find, which is that one, and it's a bit like the distance, speed, time triangle that you can use the triangle to work out what to do with the other numbers. So I'm going to be using the formula original equals final over multiplier, and that is equal to £27.20 divided by a multiplier of 0.85. We actually call this sort of problem a reverse percentage question because we are working backwards, aren't we? We know the final price and we want the original. But if you follow the method that I'm using, you just really need to be clear in your own head which is which. That gives me the answer on my calculator of 32. So the original price then was going to be £32. Okay. You can actually use this FOM triangle for any percentage question, and if you check out some of my other videos, you'll see how I apply it to all sorts of percentage questions. So make sure you go through the rest of the videos. Rearrange V equals U plus AT to make T the subject of the formula. Now you have to think a little bit about BIDMAS when you're doing these. Now BidMath says brackets, indices, division, multiplication, addition, subtraction first. So if you were working this out, you would first multiply these two together and then you would add on the u. And then when you're changing or rearranging these, you have to kind of go in the reverse order of what you would do in BidMath. So however you would calculate this if it was numbers, you have to go through the list in the opposite direction. So if I was going to evaluate u plus 80, if I knew what u, a and t were, I would times a and t together and then add on u. So rearranging it, I've got to move those in the opposite order. So I'm going to move the u first and then I'm going to move the a. We use a kind of mnemonic change sides, change signs. In other words, if I move something over the equal sign, if it's a plus on one side, it becomes a minus. If it's a times on one side, it becomes a divide. So I'm going to move this u over the equal sign. So it's going to go from plus u on the right to a minus u on the left. So I'm going to get v minus u equals a t. And then the next thing I'm going to do is I'm going to cross multiply that a. So it's times on the right hand side of the equation. So once it moves over the equal sign, it becomes divide. So it's going to be v minus u over a is equal to t. So t equals v minus u over a. Okay, and that's it. Now those of you sticking around for A-level next year might want to know that that is one of the equations of motion. Comes up a lot in your mechanics work that you're going to be doing. So one to look out for in the future. Right, 9b, complete this table with consistent metric units. Okay, so I've got distance in m, which stands for meters. Time is s, which is seconds. Speed, can you remember how these relate to each other? Some people remember this using the DST triangle, distance, speed, time. So speed is equal to distance divided by time. So if my distance is in m and I divide it by s, then I'm going to get as my units m divided by s, or meters per second. Okay? And acceleration is meters per second, or meters per second squared. You can also write this down as ms to the minus 1 and ms to the minus 2 as well, if you like. These are alternative notation. It's like index form, isn't it? 1 over s is the same thing as s to the minus 1. So, and 1 over s squared is the same thing as s to the minus 2. So there is an alternative notation that you can use there as well. Both are acceptable and both will get you the marks in this case. Multiply out and simplify x minus 8 all squared. Okay, now x minus 8 all squared is not just distributing that there and saying it's x squared minus 8 squared. That isn't right. You're going to get it wrong if you try it that way. Actually, what you need to do is rewrite this down as x minus 8 multiplied by x minus 8. It's actually a double bracket question. Now, you might have a way of remembering how to multiply this out. There are different ways. Some people call it claw, some people call it foil, some people call it 2 eyes, a nose, and a mouth. But whichever way you remember it, you have to remember to multiply everything in the first bracket with everything in the second bracket. So I've got x times x, which is x squared. I've got x times minus 8, which gives me negative 8. I've got negative 8 times x, which is negative 8x. And I've got negative 8 times negative 8, which is positive 64. Once I've written my 4 terms out like that, you'll notice I've got 2 terms in x in the middle, which I can combine together to make x squared minus 16x plus 64. And that is my final answer.
So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.